Hi all, welcome to Anil Nair classes. Today in this session, we are going to discuss perfect squares and perfect cubes, session 2. Already session 1, close to about 90 minutes of session, which we have taken, covering all the various important key points related to perfect squares. I will again start with the important key points on perfect squares. The first class was very fundamentals, very basics. Now in this class, I am going to take you to a very advanced level. By the end of the session, you will be able to solve most of the advanced level questions on perfect squares, possibly in the least possible time that you can imagine. Now straight away get into the class, perfect squares and perfect cubes. Now those of you, right, who are new to this class, kindly make a note of these important key points. My methods will work only if you work. Kindly take down a notebook and a pen. Whenever I am solving a problem, I suggest each and every student to solve it along with me each and every step. Most of my methods are unconventional methods. Most of my concepts you will not find it in the regular textbook or any of the YouTube live classes that you are watching or in any of the coaching centers on which you have invested so much money. Most of the concepts will be relatively new to you. I will take a very simple line, but I will solve some of the complicated problems to these simple lines. At the end of this session, you will be able to eliminate the use of pen or a pencil. I will make you utilize the fullest power of your brain. In case if you got any doubts at the end of the session, kindly feel free to mail us at support@anilnairclasses.com. Do not miss any of my live classes. My live class is equivalent to 20 hours of formula based learning. Most of you know it, but I'll repeat it. I was the ex-South India academic head for Career Launcher. I might have taken session more than 1000 students, minimum 500 times. You will understand why thousands of students sit in my class as and when I start problem solving. You should mandatorily sit with the notebook and a pen or a pencil. Ensure that every key point, whatever I mention, kindly make a note of that important key point in your notebook. These are some of my expectations towards all the viewers who are watching these live classes. Now, I am sure most of you know it. We stand number 1 in Google reviews all over India. If you type Anil Nair classes, Bangalore reviews, if you type it, Anil Nair classes, Bangalore reviews, you will come to know how students talk a lot about us. 3,643 students gave us a rating of 4.8 out of 5. Why this many students gave? As and when the problem starts, you will come to know. Next, straight away, let us get into the problem solving. Extremely fun-loving class, sir. I will repeat some important key points, then I will solve the problem. Perfect squares. What are the important key points that we discussed? A perfect square is any natural number if the power is an even number. If you take the power as an even number or 0, then that number is called the perfect square. Then the number is called the perfect square. Then the number is called a perfect square. Any power of a natural number, if it is even number or 0, then the number is called a perfect square. Or in simple language, a number multiplied by itself. If a number is multiplied by itself, then the number is called a perfect square. If a number is multiplied by itself, then the number is called a perfect square. A perfect square, important key points, again I am going to use it. It never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. A perfect square unit digit will never be 2, 3, 7 or 8. You take a natural number. If the unit digit of a natural number is 2, 3, 7 or 8, then definitely the number is not a perfect square. Next one, a perfect square digital sum will always be. A perfect square digital sum will always be. A perfect square digital sum will always be 1, 4, 7 or 9. 1, 4, 7 or 9. If a number is a perfect square, then the digital sum of that perfect square will always be 1, 4, 7 or 9. Reverse may or may not be true. What do you mean by reverse? You take a number, if the digital sum of that number is 1, 4, 7 or 9, it may or may not be a perfect square. But if you take a number, digital sum is other than 1, 4, 7 or 9, then definitely it is not a perfect square. Important key point. Third important key point, a perfect square will always be of the form 4k or 4k plus 1. 4k or 4k plus 1. It can also be of the form 3k or 3k plus 1. Any perfect square will be of this form 4k or 4k plus 1. Reverse may or may not be true. If a number is a perfect square, it will always be of the form 4k or 4k plus 1. If a number is of the form 3k or 3k plus 1, it may or may not be a perfect square. If this is true, this should be true. If this is true, this may or may not be true. I hope it is clear. Let us take some solved examples, then we'll go to our practice problems. These are some important key points with respect to a perfect square. I am going to use all these key points in my problems. A perfect square means a number multiplied by itself. A perfect square unit digit can never be 2, 3, 7 or 8. A perfect square digital sum will always be 1, 4, 7 or 9. If a number is a perfect square, it will always be of the form 4k or 4k plus 1, 3k or 3k plus 1. One example. Solved examples. Then we'll go to our practice problems. Solved examples. First example is 1378. Is 1378 a perfect square? Is 1378 a perfect square? Method 1, answer is it is not a perfect square because it is ending with 8. Any perfect square never ends with 2, 3, 7 or 8. This is one way to solve. Second way to solve, method 2. The last two digits of a number is 78. 78 is nothing but 4 into 19 plus 2. Any perfect square will never be of the form 4k plus 2. So it is not a perfect square. It is not a perfect square. Are you all with me? Any perfect square will never be of the form 4k plus 2. Another example. 9324 a perfect square. Is 9324 a perfect square? Is 9324 a perfect square? Now listen carefully. Any perfect square, listen to every problem, sir. Any perfect square is of the form either 3k or 3k plus 1. When this concept is used, now see here, it is ending with, now what you do is, you take it here as 9324. A perfect square will always be of the form 3k or 3k plus 1, right? If it is of the form 3k or 3k plus 1, it may or may not be perfect square. That is what I wanted to tell you. 9 plus 3, 12. 12 plus 2, 14. 14 plus 4, 18. 18 is nothing of the form 3 into 6. So it is of the form 3k. Here, a perfect square will be of the form 4k or 4k plus 1. 24 is 4 into 6. Next one, any perfect square digital sum. Now, if you see, is always 1, 4, 7 or 9. 9 plus 3, 12. 12 plus 2, 14. 14 plus 1, 4, 18. Digital sum is again 1. So, it is the converse of all these three things. All are getting satisfied. In the previous question, directly you can say that it is not a perfect square, but in this question all are getting satisfied. In such a cases, what you will do is 9324. Now if you see, We have to check whether the 9324 will give you a natural number or a dot value. Start from rightmost. Keep a slash after 2 digits. If you keep a slash after 2 digits, how many groups of 2 are there? 2 digits are there. Answer will be 2 digits. Now see here. 93. 93 lies between which all numbers? 9 square is 81, 10 square is 100. So that means it is around 90 plus something. 90 square is 8100. 90 square is 8100. 95 square is 9025. Are you all with me? 96 square is 9216. 93 square is 96 square is 80. 97 square we will do. 97 square is how much it is? 9409. Now if you observe, 9324 lies between 9216 and 9409. So it is not 96, not 97, it is between 96 to 97. That means it is not a perfect square. That means it is not a perfect square. I hope the idea is clear. Again I am explaining, not always all the numbers can be directly found out by using perfect square never ends with 2, 3, 7 or 8. A perfect square digital sum is 1, 4, 7 or 9. A perfect square will always be of the form 3k or 3k plus 1, 4k or 4k plus 1. The second is a very good example where all are getting failed. In such a cases, what to do it? You take the square root of 9324, start from rightmost, keep a slash after 2 digits. 93 lies between 9 square 81, 10 square 100. That means it is 90 plus something. 95 square is 9025. 96 square is 9216. How to find the square of a number so easily? There is a logic. Please type how to find the square of a number by Anil Nair. You will find it out. A square minus b square is a minus b into a plus b. So that means a square will become a minus b into a plus b square. This is the logic which I use it to find the square of a number very fast. Suppose if it is 96 square, a is 96. 96 is nearer to 100. Difference is nothing but 4. So answer is 96 minus 4 into 96 plus 4 plus 4 square. Answer is 9216. B is nothing but the difference between the number and the power of 10. B is nothing but the difference between the number and power of 10. That's how I got 96 square as 9216. 97 square will become 97 minus 3, 97 plus 3 square, which is 9409. 9324 lies between 9216 and 9409. Therefore, it is not a perfect square. First is a very easy question. Second is, if all the conditions are satisfied, how to check whether the number is a perfect square or not. It is not that just you execute it, you will come to know, right? What is important in my classes is why, what, when and how the concepts are being utilized. I hope the second example is very clear. I used a square minus b square logic to find out the square of a number. I realized that 9324 is greater than 96, less than 97. So answer is it is not a perfect square. Idea clear? Now I will go to the questions created by me. Third question. Now see here. X square plus 4y square is nothing but 1378. X and y are natural numbers. X and y are natural numbers. How many values x comma y will take? X square plus 4y square equivalent to 1378. X and y are natural numbers. How many values x comma y will take? Now, Anil Nair classes A and C way of solving the question. Listen carefully, sir. X square plus 4y square equivalent to 1378. Any number multiplied by 4, that means it is divisible by 4. 4y square, it is nothing but a multiple of 4. Any perfect square is of the form. So it is 4 into sum instead of x. I will take it 4 into k. Any perfect square is of the form right? Either divisible by 4 or gives a remainder 1, or gives a remainder 1. I hope it is clear. Any number multiplied by 4, it is nothing but a multiple of 4, so it is 4k. Any perfect square is of the form either divisible by 4 or it gives a remainder 1. If you add two numbers, which are divisible by 4, answer will be a divisible by 4. If you see 4y square is divisible by 4, any number which is divisible by 4 is a multiple of 4. Any perfect square is of the form 4p or 4p plus 1. If you add two numbers which are divisible by 4, answer will be divisible by 4. This gives a remainder 1. So 4p plus 4k, that means it is divisible by 4. It gives a remainder 1. Right hand side should be of the form 4 into some number or 4 into some number plus 1. I hope it is clear. 4p plus 4k divisible by 4. 4p plus 1 plus 4k gives a remainder 1. But 78 is nothing but 4 into 19 plus 2. So answer is no solution for x and y. Extremely easy question if you know this concept that a perfect square is always of the form 4 into something or 4 into something plus 1. The idea behind the question is 4y square. Any number multiplied by 4, it is divisible by 4. This only gives of the form 4 into something or 4 into something plus 1. 4p plus 4k is divisible by 4. 4p plus 1 plus 4k, it gives a remainder 1. Answer right hand side when divided by 4, it should give a remainder 1. But 78 is giving a remainder 2. Are you all with me? Extremely easy question if you know the logic. Now directly you can say this question. Please solve this question. X square plus 4y square equivalent to 9876 543210. Most of the students, those who are not attending my live classes, they will realize that this question is extremely difficult because they don't know how to solve the question. These is divisible by 4. These is something 4p or 4p plus 1. Divisible by 4 plus divisible by 4. 4p plus 1 when divided by 4, remainder 1. 10 when divided by 4, it is nothing but remainder 2. Remainder 2. So answer is, what is the answer? No solution for x and y. Extremely easy if you know the class or if you have attended my class. Other students, they will find it very difficult. They will leave this question, right? They will leave saying that the paper is tough. What is tough for my non-enrolled student will becomes a very easy question for my enrolled student. Third question. X square plus 3y square equivalent to 1, 2, 3, 2. X comma y are natural numbers. How many values x comma y will take? How many values x comma y will take? These is divisible by 3. Any number when divided by 3, either it gives a perfectly divisible or it gives a remainder 1. Are you all with me? So, but here, what is the divisibility rule of 3? Sum of the digits should be divisible by 3. 1 plus 2, 3. 3 cancel. So, what is the remainder? It is giving 3 into something plus 2, which is not matching. So, what is the answer? No solution for x and y. Very, very easy concepts if you know it. No solution for x comma y values. Are you all with me? You can do this question. You can create. That is how I create a lot of questions. 4x square minus y square. 4x square minus y square. 1373. X and y are natural numbers. How many values x comma y can take? 4x square minus y square is 1373. X comma y are natural numbers. How many values x comma y will take? 4x square. Any number divided by 4, it is divisible by 4. Minus of any perfect square is of the form either 4x or 4x plus 1. Are you all with me? When you subtract two numbers divisible by 4, answer will be divisible by 4. 4p minus 4x. 4p minus 4x divisible by 4. Remainder is 1. So 4 into w minus 1. So answer should be of the form either when divided by 4, it should be perfectly divisible or it gives a remainder minus 1. What is the divisibility rule of 4? Last two digits should be divisible by 4. 73 is 4 into 18 plus 1. I want minus 1. I want minus 1. So answer is no value for x comma y exists. No value for x comma y exists. Are you all with me? No value is possible because the right hand side should be of the form 4w minus 1. That means when you divide a number by 4, when you divide a number by 4, negative remainder minus 1 means positive remainder will be 3. For example, suppose 15 divided by 4. 4 3s are 12. Negative remainder minus 1. Positive remainder will be 3. Positive remainder will be 3. Negative remainder minus 1 means positive remainder 3. In this question, nothing I did it. There is no algebra here. There is a simple definition of perfect square I used in this question. 4x square. Any number multiplied by 4, it will be divisible by 4. Perfect square. Any perfect square is of the form 4x or 4x plus 1. 15 when divided by 4. 4 4s are 16, negative remainder minus 1. If you got a negative remainder minus 1, positive remainder is nothing but 3. So in this question, if the negative remainder is minus 1, right, positive remainder should be 3. That means in this question, right hand side when divided by 4, when divided by 4 means last two digits should be divided by 4, remainder should give you 3, but 73 when divided by 4, remainder it gives 1. So answer is no value. I hope the idea is clear. All are based on the definition of a perfect square. One more question. If you see the equation, 3x square minus y square equivalent to 1321, xy are natural numbers. How many values xy will take? Again, a very simple understanding of perfect square definition you will come to know. 3x square, any number multiplied by 3, it is 3p. Y square, it is a perfect square. Any perfect square is of the form when divided by 3, remainder 0 or remainder 1. So, if you subtract two numbers, it is divisible by 3. So, this will give a remainder minus 1. When you divide a number by 3 and the negative remainder is minus 1, positive remainder will be 2. Negative remainder minus 1, positive remainder will be 2. Let us check the remainder when you divide a number by 3. The divisibility rule of 3 is sum of the digits should be divisible by 3. Remainder is 1. But I got 2. So answer for this question is no solution for x comma y. I hope you are understanding the concept. No solution for x comma y exists. All the questions are based on the concept. A perfect square will always be of the form either 4 into something or 4 into something plus 1, or when divided by 3 remainder 0, or when divided by 3 remainder 1. One more question we will solve. Suppose if the question is like this, x square plus y square equivalent to 3479. X comma y are natural numbers. How many values x comma y can take such that it satisfies the equation? It is a perfect square. Any perfect square is of the form when divided by 4 remainder 0, or when divided by 4 remainder 1. This is the form of x square. It is also a perfect square. Any perfect square will be of the form when divided by 4 remainder 0 or remainder 1 plus. You take all the combinations. If I add these two numbers are divisible by 3. 4, answer will be divided by 4. This gives a remainder 1. This gives a remainder 1. This gives a remainder 2. That means when you divide a number by 4, in these cases, either 0 we got, 1 we got, or 2 we got. 0 is in this case, 1 is in this case, 2 is in this case. These are the possible reminders. These are the possible reminders. But according to the right hand side, 79. 79 when divided by 4. 4 19s are 76. What is the remainder? 3. Remainder 0, 1, 2 are only possible. So no solution for x comma y exists. No solution for x comma y exists. I hope the idea is clear. I hope the idea is clear. Idea clear, right? This question can also be solved in another variety. This is method 1. I hope the method 1 idea is very clear. Simple usage of definition of a perfect square, you will get this logic. Definition of perfect square. Any perfect square is either divisible by 4 or remainder 1. When divided by 4, remainder 0, remainder 1. Possible remainders are 0, 1, 2. But I require remainder 3. Next, one more question. Same thing, method 2 we will do. X square plus y square equivalent to 3, 4, 7, 9. X comma y are natural numbers. How many values x comma y will take? X square plus y square equivalent to 3, 4, 7, 9. Now see method 2. Method 2 is also a very easy type. Method 2. X square plus y square equivalent to 3, 4, 7, 9. Unit digit of this number is 9. If it is 9, 0 plus 9, 9, 1 plus 8, 9, 2 plus 7, 9, 3 plus 6, 9, 4 plus 5, 9. 4 plus 5 unit digit 9. Remaining all are the reverse of these cases. 5 plus 4, 9, 6 plus 3, 9, 7 plus 2, 9, 8 plus 1, 9, 9 plus 0, 9. Are you all with me? X square and y square are perfect squares. A perfect squares never end with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. All these cases are not possible. Any perfect square ends with even number of zeros. Perfect square ending with 9 tens place is even. Any perfect square ending with 4 tens place is even. Any perfect square ending with 5 tens place is 2. Even plus 2, it is an even number. That means tens place should be an even number. 0 plus even, it is an even number. Tens place should be an even number. Tens place according to the unit digit logic should be an even number. But according to the question, tens place is an odd number. Answer is no value for x comma y exists. Answer is no value for x comma y exists. I hope the idea is very clear. X square plus y square equivalent to 3, 4, 7, 9. Right hand side unit digit is 9. So I played with the unit digit in the left hand side. 0 plus 9, 9. 1 plus 8, 9. 2 plus 7, 9. 3 plus 6, 9. 4 plus 5, 9. Any perfect square ending with 9 tens place even. Perfect square ends with 0, 0. So it cannot end with 8, 2, 3 or 7. 4 plus 5 is 9. Even plus even is even. 0 plus even is even. Tens place should be even. But according to the question, tens place is odd. Therefore, no value for x comma y exists. Idea clear, right? One more question. Each and every question concentrates on a lot of ideas. X square plus y square equivalent to 1544. X comma y are natural numbers. X comma y are natural numbers. How many values x comma y satisfies the equation? X square plus y square equivalent to 1544. Now see the solution. Very easy way to solve the solution if you understand the approach. Now see the question. Each and every question, whatever we are solving right now, ensure that you solve it right after the end of the class also once again. Most of the problems or most of the concepts you will not find in any of the YouTube channels. You can sit and do aram se all these questions research in Google. Everybody will solve the standard textbook problems right now. In this class I create questions. That is the difference. X square plus y square equivalent to 1544. Now see here, the unit digit in this question is 4, 0 plus 4 is 4, 1 plus 3 is 4, 2 plus 2 is 4, 4 plus 0 is 4, 5 plus 9 is 4, 6 plus 8 is 4, 7 plus 7 is also 14, 4. Are you all with me? Right, 6 plus 8 is also all the cases which we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the digits we got. X square and y square are perfect square. A perfect square can never end with 2, 3, 7 or 8. These cancelled, these cancelled, these cancelled, these cancelled. Any perfect square ending with 0, tens place should also be 0. Here I require 4 at the end. So this has to be 4. So what is the smallest number that will end with 44? Y square ends with 44. That means y value is 12. Are you all with me? Y value is 12. Y value is 12. So if y value is 12, which are all the logics that I will get? y square. 50 is complement. 50 plus y whole square or 50 minus y whole square will give same last two digits. 50 plus y square, 50 minus y square should give same last two digits. 12 square. 50 plus 12, 62 square. 50 minus 12, 38 square. These anyway greater than 1544. Right? Now if I take 144, this will become 144. This will become 1400. X square cannot be 1400. So the case that is not possible is 12 and 62. If I case that is not possible is 12 and 62, the case that is possible is 38 square. So 38 square is nothing but 1444 plus 100. So x is 38, y is 10. This is one solution. X 38, 110, this will satisfy the solution. 5 and 9. Any perfect square ending with 9 tens place is even. 7 square 49, 13 square 169. Any perfect square ending with 5 tens place is 2. 9 plus 5, 14, 1 carried. 2 plus even is even, 1 plus even is odd. But according to the question, tens place should be even. So this case is eliminated. So the only case that will satisfy this question is x is 38, y is 10. Extremely high level conceptual questions. Generally in every textbook, a statement will be written. From that statement, I will create so many questions. A student will understand the importance of the statement that is given. X square plus y square equivalent to 1544. The root cause is right hand side unit digit is 4. 0 plus 4, 1 plus 3, 2 plus 2, 3 plus 1, 4 plus 0, 5 plus 9, 6 plus 8, 7 plus 7. A perfect square can never end with 7, can never end with 2, can never end with 8, so can never end with 3. All these cases are eliminated. The only case that is possible is 0, 4 and 5, 9. 5 and 9 is not possible because any perfect square ending with 5 tens place has to be 2. 5 square 25, 15 square 225, 25 square 625, 35 square 1225. Any perfect square ending with 9 tens place is even. 9 plus 5, 14, 1 carried. 1 plus even is odd. But according to the question, tens place should be an even number. So the case that is possible is, right, 0 and 4. Last two digits are 44. Y square ends with 44. What is the smallest natural number? Y that will end with 44. Y value 12. 12 square, 50 plus 12 square, 50 minus 12 square. 50 minus 12 square is 38 square. 38 square is 1444. Remaining x square 100. So x value will be 10. Please put a star mark on this question. Revisit this question after the class is over. All the questions are based on perfect squares. Perfect squares. I hope it is clear, right? Idea clear? All the questions are based on a perfect square logic. I am sure the solved problems are very clear to you. Now let us go to practice problems. Now see the first question. All are very good questions. How many numbers are of the form 1, 1, 1, 1, 1, 1, 1, 1, 1 and so on are perfect squares? You can solve the problem in two methods. Method 1. All are ending with 1. What is the nature of a perfect square ending with 1? 9 square 81, 11 square 121, 19 square 361, 21 square 441. Any perfect square ending with 1. Tens place should be an even number. Tens place should be an even number. According to the question, tens place is an odd number. Answer is 0 numbers are perfect squares. There is no number except perfect square from the series 1, 1, 1, 1 and so on. So answer is only one number. Answer is 1. These 0 numbers from here, none of the numbers are perfect squares because any perfect square ending with 1, tens place should be an even number. For 11, tens place is an odd number. 111, tens place is an odd number. 11, 111 and so on. All these are eliminated. Only number which is a perfect square is 1. I hope the idea is clear. Method 1. Method 2. Method 2. Any perfect square is of the form. Any perfect square will be of the form either 4 into something or 4 into something plus 1. Every perfect square should be of the form 4p plus 1. Suppose if I take from 11, 111, 4 ones, you take from all this case, what are the last two digits of that number? Last two digits of a number is 11. 11 is nothing but 4 into 2 plus 3. 4k plus 3 does not arise for perfect square. Answer for this question is 1. I hope the logic is extremely clear to you. Either you can go by the tens digit unit digit logic, or you can go by the perfect square form. A perfect square is always of the form 4 into something or 4 into something plus 1. Method 1, method 2. Depending upon your observation, you can take any that thing that is possible. Next one, how many numbers are of the form 1, 1, 2, 3, 1 and so on up to the last number is 1, 2, 3, 4, 5, 6, 7, 8. How many numbers in this series? 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. These 1, next is 1, 2, next is 1, 2, 3, next is 1, 2, 3, 4, next is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Multiple logics we will use. What is the first logic? A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. All these four cases are out. Any perfect square ending with 4, tens place should be an even number. 8 square 64, 12 square 144, 18 square 324. Tens place is an odd number. Any perfect square ending with 5, tens place is always 2. 5 square 25, 15 square 225. Any perfect square ending with 6. Any perfect square ending with 6. 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6. We have to check whether this number is a perfect square or not. Now see here. 1, 2, 3, 4, 5, 6. Now if you observe this question, it is ending with 6. So 56 is also divisible by 4. Digital sum also 6 plus 3, 9, 5 plus 4, 9, 2 plus 1, 3. So perfect, it is giving you digital sum how much? Digital sum 3. What is the perfect square logic? A perfect square digital sum should always be, a perfect square digital sum is always 1, 4, 7 or 9. But according to the question, what is the digital sum we got? 3. So these cancelled. So the only number which is a perfect square is nothing but 1. Very simple example which explains multiple concepts. A perfect square never ends with 2, 3, 7 or 8. Depending upon the unit digit, tens place will be there. Already we discussed one beautiful logic. A perfect square tens place is odd number only when the unit digit is 6. Only when the unit digit is 6, tens place is an odd number. This logic I used. A perfect square digital sum is 1, 4, 7 or 9. I hope second problem is also clear to you. Third one. Another one. How many numbers are of the form 4, 44, 444 and so on? Suppose if I take 4 common, these are nothing but 1, 11, 111, these are nothing but and so on. All this. In this one, all these numbers starting from the second number are of the form 4p plus 3. A perfect square will never be of the form 4p plus 3. So answer is only one number and the number is nothing but the first number. Answer is 4. I hope the logic is clear. A perfect square will never be of the form. A perfect square will never be of the form 4p plus 2 or 4p plus 3. Each and every question are created out of a lot of research and to make a student absolutely understand the beauty of this concept. If you miss any of these classes, right, show whatever I am sharing these logics with your friend, probably in your coaching center, in your, right, any of the online classes. This concept is not taught. Most of the concepts that are taught are nothing but the problems taken from the books, right, and most are rote based learning. I hope it is clear. Next one. How many 5-digit perfect squares? that can be formed using the digits 1, 2, 3, 4, 5. There are 5 digits 1, 2, 3, 4, 5. Each digit is used exactly once. Each digit is used exactly once means repetition of digits is not allowed. Repetition of digits is not allowed. When you are using 5 digits in a 5 digit number exactly once, that means repetition of digits is not allowed. Repetition of digits is not allowed. So one number could be of the form 1, 2, 3, 4, 5. Next number could be of the form 2, 5, 4, 3, 1. Next number could be of the form 5, 4, 1, 2, 3 and so on. Are you all with me? 1, 2, 3, 4, 5, 2, 5, 4, 3, 1, 5, 4, 1, 2, 3 and so on. Now if you see the digital sum of these number, digital sum of these number is nothing but even in whatever the order that you do it, digital sum will not change. So summation 5. Summation 5. Summation 5 is nothing but 1 plus 2 plus 3 plus 4 plus 5. Summation 15. 15 is nothing but digital sum 6. Digital sum 6. So all the 120 numbers that are formed, what are the 120 numbers? 5 numbers arranged in 5 places, it is 5 factorial, which is 120. All the 120 digit numbers, irrespective of the order in which the digits are written, sum of the digits is always 6. A perfect square digital sum will be 1, 4, 7 or 9. So answer for the question is 0. Answer for this question is 0. I hope the idea is clear. Sum of the digits is 15. 15 is 6. For a number to be a perfect square, its digital sum should be 1, 4, 7 or 9. Idea clear? Now another question. How many 3-digit numbers ABC will satisfy the condition ABC equivalent to A cube plus B cube plus C cube? This is nothing but an Armstrong number. This is nothing but an Armstrong number, one of the very few numbers where you started doing your initial numbers. There are, right, 153 is one such Armstrong number, 307 is one such Armstrong number, 317 is another Armstrong number, 407 is another Armstrong number. If you see, these are nothing but 1 cube plus 5 cube plus 3 cube. 125 plus 27, 152 plus 1, 153. 3 cube plus 0 cube plus 7 cube. 343 plus 27 is 370. Sorry. 371. 371. I wrote a mistake here. It is 371. It is 371. 370. Next is 371. 3 cube plus 7 cube plus 1 cube. This is also nothing but 4 cube plus 0 cube plus 7 cube. 343 plus 64, which is nothing but 407. In a 2-digit numbers, there are 4 such Armstrong numbers: 153, 370, 371 and 407. Like that, in a 5-digit number, 6-digit number, there are some numbers 655053. Like that, there are so many Armstrong numbers that are there. Now these are the 4 such numbers which will satisfy. Instead of doing 4 different values, I will show you how 153 is obtained for one such value. Same process you can find it out. You will get 370, 371, 407 also. Now proof. Why 153 is coming out to be 1 cube plus 5 cube plus 3 cube. I will prove this. So that the same pattern can also be followed by 370, 371 and 407. Now see here, ABC is a 3-digit number. If ABC is a 3-digit number, C is there in units place, B is there in tens place, A is there in hundreds place. $100A plus 10B plus C equivalent to A cube plus B cube plus C cube. Let me take A value 1. If I take A value 1, 100 plus 10B plus C equivalent to 1 plus B cube plus c cube. So this is nothing but b cube plus c cube equivalent to 99 plus 10b plus c. I hope this equation is clear. B cube plus c cube is 99 plus 10b plus c. Now b cube plus c cube minimum value, b cube plus c cube minimum value will be when b is 0 and c is 0, that is 99. B cube plus c cube maximum value is when b equivalent to 9, c equivalent to 9, which is 198. 198. Listen carefully, sir. B cube plus c cube minimum value is when b is 0, c is 0. B cube plus c cube should start from 99, should end at 99, because the maximum digit b and c can take is when. From this equation, I can say that b and c will definitely be less than 6. Because if I take 6 cube plus something, 216 plus something cannot be 198. B value cannot be 6. So let me take b value 5. If I take b value 5, what will be the equation will become? So this will become 5 cube plus 6c cube equivalent to 99 plus 50 plus c. C cube minus c is nothing but 99 plus 50, 149, 149 minus 25, 24. So these is nothing but c into c square minus 1 is c into c minus 1 into c plus 1 is 24. C is 3. Because 3 into 2 into 4 is 24. A value 1 we got, B value 5 we got, C value 3 we got. So the number is nothing but 153. Are you all with me? Similarly, try it out for A value 2. Similarly, try it out for A value 3. Like that, you will get cases. There are 4 different values, means there are 4 different equations that you have to do it. You only thing you have to do it is for A value 1, 2, 3, 4 and 5, you have to do it. I hope this equation is clear. There are 4 numbers that will satisfy, which are called as an Armstrong number: 153, 370, 371 and 470. These are the 4 Armstrong numbers which will satisfy this property: ABC equivalent to A cube plus B cube plus C cube. Very, very good question. One of the first few C programs which you will write when you enter into the first year of engineering. Next one, another good question. Find the smallest positive integer. I want the smallest positive integer. N greater than or equivalent to 2. 2 square minus 1. 2 square minus 1 is nothing but 2 minus 1 into 2 plus 1, which is nothing but 1 into 3. 3 square minus 1. 3 square minus 1 is nothing but 3 minus 1 into 3 plus 1, which is again nothing but 2 into 4. 4 square minus 1. 4 square minus 1 is nothing but 4 minus 1 into 4 plus 1, which is 3 into 5. Next one, 5 square minus 1. 5 square minus 1 is nothing but 5 minus 1 into 5 plus 1, which is nothing but 4 into 6. That means if you observe, 3 is becoming 3 square, 4 is becoming 4 square, 5 will become 5 square. So n square minus 1, which is nothing but n minus 1 into n plus 1. If n is there, previous number will become n minus 1 square minus 1. So which is n minus 2 and n. So all the numbers, if you observe, all the numbers, first 2 are remaining and last 2 will be remaining. N minus 2 into n. So the last it will be n minus 1 into n. Remaining all will have a squares. 3 into 3 is 3 square, 4 into 4 is 4 square, 5 into 5 is 5 square, like that. So what will be remaining is 1 into 2 into 3 into 3, 3 square, 4 into 4, 4 square, 5 into 5, 5 square. First 2 and last 2. First 2, n minus 1, n plus 1. N minus 1, n plus 1. First 2 and the last 2 will be remaining. This 2 and this 2 will be remaining. So n into n plus 1, this is nothing but a perfect square, which is k square. So 2n into n plus 1 into all these 3 square, 4 square, 5 square and so on. That is nothing but another perfect square equivalent to k square. This is a perfect square, this is a perfect square. So this should be a perfect square. For it to be a perfect square, already 1, 2 is there. So extra 1 if I, extra 2 if I keep, 2 into 3, which is not a perfect square. So 1, 2 is there. Power of 2 should be an even number to get a perfect square. If I take 2 cube, so this is nothing but 2 into 8 into 9. 72 2s are 144. 144 is a perfect square. So the value, smallest value that will make this term perfect square is n is 8. It is a simple calculation problem. 1 into 3, 2 into 4, 3 into 5. If you observe, 3 into 3, 3 square, 4 into 4, 4 square, 5 into 5, 5 square and so on. So only the first two and the last two will be there. Only the first two and the last two will be there. See, simple thing what you can do is, you take for 3 numbers, you will understand why the first and last are only there. If you observe, first two and the last two. 3 into 3, 3 square, 4 is also a perfect square. You can take smaller values and check it out how many different values are there. It's a very good question. Most of the questions are relatively new question. Please practice good conceptual content. Practice less number of problems but variety of problems rather than practicing one variety of problems 100 times. I hope it is clear. Next one. Another beautiful question, sir. Please take 1 minute to read the question. Take 1 minute to read the question. Read the question first. A is a 3-digit number. ABC is a 3-digit number. ABC is a 3-digit number. ABC is a 3-digit number. If you strike out the leftmost digit of A, leftmost digit is A. If I strike it out, BC is a perfect square. BC is a perfect square. Okay. What are the 2-digit perfect square? 3 square is 0, 9. It is 4 square, 5 square, 6 square, 7 square, 8 square and 9 square. Are you all with me? BC is a perfect square. What is another? If you strike the extreme rightmost, see if I delete, AB is a perfect square. AB is a perfect square. That means it's, if I strike 6, remaining number should be a perfect square. What is the nature of a perfect square ending with 1? Tens place should be even. So 81 is perfect square. This perfectly shooting. If I strike out 5, this number will end with 2. A perfect square never ends with 2, 3, 7 or 8. If I strike out 6, it will end with 3. A perfect square never ends with 3. A perfect square ending with 9. What is the nature of a perfect square ending with 4? Tens place should be an even number. 0, 4. 0, 4 will become a 2-digit number. 24. 24 is not a perfect square. 44 is not a perfect square. 64 is a perfect square. So if I remove 6, 49 is a perfect square. If I remove 9, 64 is a perfect square. Are you all with me? If it is 1, tens place will become 8. A perfect square never ends with 2, 3, 7 or 8. If it is 4, any perfect square ending with 6, tens place should be an even number. So it can be 1 or it can be 3. 16 is a perfect square, 364 is a perfect square. How many numbers we got? 816 we got one number, 164 we got one number, 364 we got one number, 649 we got another number. If you observe the beauty about this question, 816, you remove leftmost, 16 is a perfect square, 64 is a perfect square, 64 is a perfect square. 49 is a perfect square. Here 64 is a perfect square, 36 is a perfect square, 16 is a perfect square, 81 is a perfect square. How many such numbers are there? 4 numbers are there. All the questions whatever we are discussing today are nothing but a perfect square. You will start wondering, from a small concept in number system, this many questions can be developed. Yes, the answer is yes. After this class, you will not be You will never feel like listening to anyone's class in terms of the concepts. I can vouch for it. I can say it with experiential authority and the kind of research I have done in the world of mathematics. Right? Every possible question I kept it here. ABC. BC is a perfect square. I hope it is clear. There is a 3-digit number. Remove leftmost, remaining 2 will be a perfect square. Remove rightmost, remaining 2 will be a perfect square. 4 such numbers I got. Next one. If x and y are integers, very good question, sir. If x and y are integers in the range 1, 40, if there is a rectangular number box, that means it is including 1 and 40. Including 1 and 40. If the box is like this, open bracket, closed bracket, it is like this, that means excluding 1 and 40. Excluding 1 and 40. Including 1 and 40. How many pairs of x comma y? Is x comma y a perfect square? X comma y should be a perfect square. X comma y should be a perfect square. This expression x comma y will be a perfect square under 2 cases. Any perfect square power should be an even number. Power should be an even number. How many even numbers are there? 20 even numbers are there. From 40 numbers, 20 are even, 20 are odd. X can take any value from 1 to 40. So total 40 values are there. Are you all with me? So if it is for 1 square is 1 value. 1 square, are you all with me? So 40. 40 into 20. 800. 40 into 20. Are you all with me, sir? 40 into 20. X can take any value. X can take any value. Here please observe what are that values that I am taking. 1 square, 1 power 4, 1 power 6 and so on up to 1 power 40. Next is 2. 2 square, 2 power 4, 2 power 6 and so on up to 2 power 40. Are you all with me? If it is 40, 40 square, 40 power 4 and so on up to 40 power 40. Yes or no? Perfect square means power will be an even number. So each value, each from 2 to 40, 20, like that 40 numbers are there. 40 into 20, 800. In this one, 19 values will give a same number. 800 minus 19 is 781. 781. Are you all with me? This is only case number 1. Right? I think he has not. X and y are distinct numbers. How many pairs is x comma y? How many pairs only is asking, right? How many values he is not asking. So here, I hope you have understood what am I doing. 40 into 20 is 800. He is not asking you the distinct values for x comma y, because how many pairs? 1 square is 1 pair, 1 power 4 is another pair, 1 power 6 is another pair, 1 power 40 is another pair. You cannot write 1 power 4, 1 power 6, all they are giving one value, but the question is how many values x comma y will take. So it is 800. I hope it is clear. What is this case 1? Case 1, x comma y is a perfect square when y is an even number. When y is an even number and x is a x could be an any number. Perfect square means power should be an even number. Case 1 clear. Case 2. Case 2. One more case also I will get it. This is the case where most of the students will miss it. X comma y is a perfect square. What is the next case that will miss it? Case 2. Case 2 is y can be an odd number. Y can be an odd number and x can be a perfect square. All these will also give x comma y a perfect square. So 1 square, 2 square, 3 square and so on up to 6 square. Are you all with me? Because I cannot take 7 square 49. Range is from 1 to 40. So 1 square power 1, 2 square, 1 square power 3. Are you all with me? 1 square power 1, 2 square power 1, 2 square power 1, 2 square power 3, 2 square power 5, 2 square power 7 and so on. So odd number, how many values are there? Total 20 odd numbers are there. Perfect squares means total 6 numbers are there. Because what is the perfect square less than 40? 6 square is 36, 36 is less than 40. So 20 into 6, 120 combinations. Previously I got 800, now I will get 120. So the total answer is 920. Total answer is 920. Most of the students will tick mark the answer as 800, which is incorrect. For a power x power y to be a perfect square, there are two cases. Y could be an even number or y could be an odd number. If y is an even number, the base could take any value. If y is an odd number, the base could take only perfect squares. The only perfect squares. Extremely important, sir. If it is of the form x power y, y could be an even number or y could be a perfect square. Y could be a odd number. If y is an odd number, x will be a perfect square. Here x could be any integer. This is a very important observation. I have seen a lot of students doing mistake in this question, because till now we discussed that a perfect square power will be only be an odd even number. A perfect square can also have power an odd number and the base as a perfect square. Are you all with me? Base can be a perfect square, power can be an odd number, base could be anything, but the power can be an even number. Extremely important questions, sir. Quality questions. Next one. The sum of 4 consecutive 2-digit odd numbers. 2-digit odd numbers. Odd numbers will have odd unit digit. Odd numbers will have odd unit digit. What are the unit digits possible for an odd number? 1, 3, 5, 7. Yes or no? 31, 33, 35, 37. It can also be 3, 5, 7, 9. 33, 35, 37, 39. 5, 7, 9, 1. 45, 47, 49, 51. 77, 79, 81, 83. 19, 21, 23, 25. Yes or no? These are all the possible 4-digit unit digits. 1, 3, 4, 7. He said sum of 4 consecutive 2-digit odd numbers. 11, 13, 15, 17, they are an odd numbers. 13, 15, 17, 19, they are also an odd numbers. 15, 17, 19, 21, these are also an odd numbers. 27, 29, 31, 33, these are also an odd numbers. So these are the 5 ways. But he said something. Sum of 4 consecutive 2-digit odd numbers when divided by 10. When you divide a number by 10, unit digit should be 0. When you divide a number by 10, unit digit should be 0. Let us see. 7 plus 5, 12, 15, 16, unit digit is not 0. 16, 21, 24, unit digit not 0. 12, 21, 22, unit digit not 0. 16, 17, 20, unit digit 0. 9, 1, 3, 5, unit digit is 8, not 0. So that means 7913. 7913. Now if you plug in an answer option, easily you get it. Answer becomes a perfect square. What is the first option? 21. So if you plug in this value, if this is 21, this is 23, this is 17, this is 19. 17 plus 19, 36, 36 plus 44, 80. 80 is not a perfect square. 25. If it is 25, 25 case is not possible, because the unit digit should be 7913. If I take 41, 41, 43, 37, 39, 76 plus 84, 160. 160 when divided by 10, 16. 16 is a perfect square. Beautiful question which explains you, right, how to remove the incorrect values just based on condition. First he gave there are 4 consecutive 2-digit odd numbers. He said then it becomes divided by 10. Then the answer when divided by 10, it is a perfect square. 1357 one value. 3571. It could be it is not necessarily starting with 1. It could be 1357, it could be 3579, it could be 5791, it could be 7913, it could be 9135. Because it is divided by 10, unit digit should be 0. Unit digit 0 is possible in only one case, that is 7913. Idea clear? Idea clear, right? 41. Another question. From all natural numbers, there are a natural numbers from 2 to 10,000. Okay. First, all the perfect squares are erased. That means there is a round 1. In round 1, perfect squares are erased. 2 square, 4 is erased. 9 is erased. 16 is erased. All the perfect squares are erased. Okay, clear? Then all the perfect cubes are erased. Then all the perfect cubes are erased. 2 cube, 3 cube, 4 cube, and so on. Clear? Then all the perfect fourth powers are erased. Fourth powers are erased. See, I cannot take 2 power 4 because 2 power 4, this case already came in round 1. Fourth power is nothing but the second power, right? At least one number is erased in them. Round 1, all the perfect squares are erased. Round 2, all the perfect cubes are erased. In round 3, you cannot erase fourth powers because fourth powers are already erased. Fourth power is nothing but the square of the square power. 2 power 4 already came it as 4 square. That means in round 3, instead of doing fourth power, I will do the fifth power. 2 power 5, 3 power 5, 4 power 5, and so on. Idea clear? Next, in round 4, I cannot do 6th power. 6th power is nothing but the square of the cube power. 6th power is nothing but the square of the cube power. So 6th power I will not do. 7th power I will do. Are you all with me? 6th power. 2 power 6 is nothing but 8 square. Right? 2 power 4 is nothing but 4 square. I hope you are understanding why we are eliminating 4th powers and 6th powers. Round 5. 8th power I cannot do it. 8th is nothing but a power 4 whole square. 8th is nothing but 2 power 4 power 2. 8 comes in 2. 8 comes in 2. 9 comes in 3. 10 comes in 5. 11 will not come. So only the prime powers I am eliminating. I hope the logic are clear. Prime powers I am eliminating. Prime powers I am eliminating. So 2 power 11 will become, 2 power 10 is 1024. 2 power 11 will become 2048. So round 12, 6. 2 power 12 cannot be eliminated. 12 is nothing but it is already eliminated in square and square power or in power 3. Round 6. 2 power 13. 2 power 13 is nothing but 8 into 1024, which is less than 10,000. I need to stop here because the maximum upper limit a value can take is 10,000. So at least one numbers are erased in how many? 1, first, second, third, fourth, fifth, sixth. Answer is 6. Are you all with me? By default, what the mistake most of the students will do it is, they will take 2 power 4, they will take 2 power 6, they will take 2 power 8. Answer is nothing but the prime powers. The answer is nothing but the prime powers. What are the prime? What is the 2 power n? Because it is starting from 2. 2 power n. 2 power n. 2 power n is nothing but 2 power n is nothing but less than 10,000. 2 power n is nothing but less than 10,000. I hope the idea is clear. Please look into each and every question of mine. Each and every question is a quality question. M and n are two positive integers that satisfy the equation n cube plus 2n square equivalent to m square. 1 less than or equivalent to n less than or equivalent to 1000. This is nothing but n square into n plus 2 is nothing but m square. N square is a perfect square. N square is a perfect square. M square is also a perfect square. M square is also a perfect square. So this should be a perfect square. This should be a perfect square. N plus 2. I cannot take 1 square because n will be negative. N is a positive integer. 2 square, 3 square, 4 square, and so on up to. Write 1000. 1000 means 31 square is 961. 32 square is 1024. From 2 to 31, total 30 values are there. Total 30 values are there. N cube plus 2n square equivalent to m square. So n square into n plus 2 is m square. N square is a perfect square. M square is also a perfect square. N plus 2 should be a perfect square. For n plus 2 should be a perfect square, n plus 2 can take any value from 2 square to 31 square, because the upper limit that is given in the question is 1000. 31 square is 961. 31 square is 961. I hope the idea is clear. I cannot take 1 because n plus 2 1 square, n value will become negative. N is a positive integer. N is a positive integer. I hope the idea is clear. Next one. Find the prime number p such that 71p plus 1 is a perfect square. 71 plus 1 is nothing but a perfect square. Perfect square is of the form k square. So k square minus 1 is nothing but 71p. These are nothing but k minus 1 into k plus 1 equivalent to 71p. The catch in the question is p is a prime number. A prime number cannot be decomposed further. So only two cases I will get, 71 into p or p into 71. Are you all with me? So that means if k minus 1 is 71, k will become 72, and k plus 1 is equivalent to p, p will become 73. 73 is a prime number. 73 is a prime number. So this case it is possible. Suppose if I take the next case, k minus 1 p, k plus 1 is nothing but 71. K value is nothing but 70. 70 minus 1 is 69. 70 minus 1 is 69. 69 cannot be a prime number. So the only case that is possible is p value is 73. Beautiful question, sir. The condition in the question is p is a prime number. 71p plus 1 is k square. K square minus 1 is 71p. K minus 1 into k plus 1 is 71p. P is a prime number. So it cannot be decomposed further. 71 into p or p into 71. K minus 1 71, k is 72. K plus 1 p. K value 72 means 72 plus 1 is 73. Idea clear, right? Second case is not giving you p as a prime number. A good question based upon the definition of a prime number. Next one. Find all the positive integers n for which 2 power m plus 2 power 7 plus 2 power n is a perfect square. Mistake. Most of the students will do this mistake first. What is the mistake we will see? A plus b whole square is a square plus 2ab plus b square. So these is nothing but 2 square whole square. These 2 into 2 square, 2 cube. Next is 2 power 4. So they will write 2 power 4 whole square. So these is nothing but 2 power 4 plus 2 power 7 plus 2 power 8. Please check whether this number is giving you perfect square. Check it out. 16 plus 128 plus 256. 256 plus 16 is 272. 272. 272 plus 128, which is 400. 400 is nothing but a 20 square. Are you with me? So 2 power 4 is 16 plus 128 plus 256. 256 plus 16, it is 272 plus 128, 400, 20 square. Always remember, whenever you are doing, this sum should be a perfect square. If the sum is a perfect square, if you are getting perfect square, then this approach is right. Right? If the sum is not giving you perfect square, after doing this, please check whether the sum is a perfect square. If the sum is not a perfect square, then you are in a danger zone. Are you all with me? To avoid these danger zone, let us do a method 2 approach. Method 1, I hope it is clear. A plus b whole square is a square plus 2ab plus b square. So 2 power 4 plus 2 power 7 plus 2 power 8. 2 power 8, 256, 128, 16. I am getting 400, which is a perfect square. There is also another approach to solve this question. That is 2 power 4 plus 2 power 7 plus 2 power n. It is a perfect square. 144 plus 2 power n, which is nothing but k square. K square minus 144 is nothing but 2 power n. This is nothing but k minus 12 into k plus 12. It is nothing but 2 power n. Listen carefully, sir. Listen carefully. What is the difference between these two numbers? Difference between these two numbers is 24. K plus 12 minus of k minus 12. 24. Let us see where is the difference. 24. 2 power 1 is 2. 2 square is 4. 2 cube is 8. 2 power 4 is 16. 2 power 5 is 32. What is 32 minus 8? 24 I am getting. Are you all with me? So this can be 2 cube and this can be 2 power 5. So k minus 12 can be 8. That means k value 20, or k plus 12 is 32, k value 20. There also in the previous case we got k value 20. I hope it is clear. Add the values and check whether the number is a perfect square or not. Most likely it will be a perfect square, just for our right safeguarding our calculation and the values, right, and checking whether are there any more values. That first method has given you directly one value. Directly only one value it has given, right? There could be a chances of getting, for example I gave a question. Suppose for example, if the difference is 4, why I said the previous method may not be the best method is, suppose for example, if the right hand side is, if this is 4, there could be a case 6 minus 2 is 4, or there could be a case 8 minus 4 is 4. Are you all with me? Are you all with me? There could be a possibility of more than one case where the powers of 2 difference can also be there. So please cross check it once again. Always I advise you to go with method 2. Method 2. I hope the idea is clear, right? Next one. Find all the integers for which the quantity n square plus 19n plus 92 is a perfect square. N square plus 19n plus 92, it is a perfect square. I will multiply with 4. I will tell you why am I multiplying. 4n square plus 17n plus 368 equivalent to k square. Can I write it as like this? 2n plus 19 whole square. 2n whole square is 4n square. 2 into 2n, 4n into 19 is 76 plus 7 equivalent to k square. This is nothing but k square minus of 2n plus 19 whole square equivalent to 7. So these k plus 2n plus 19 and k minus 2n minus 19. 7 is nothing but a prime number. You can write it as 7 into 1. So if I add it, k plus 2n plus 19 is 7. K minus 2n minus 19 is 1. So 2k is nothing but 8. K value is nothing but 4. I hope it is clear, right? Clear? If I substitute 4 here, this equation will become n square plus 19n. 4 square is nothing but 16. So it is nothing but 16, 92. 92 k square, where is the mistake? So 2k, okay, I think what we did is, it is 4k square, it is 2k square, it is 2k, it is 2k, it is 2k. Are you all with me? It is 2k, it is 2k, it is 2 into 2k, it is 2 into k. So k value is 2. If k value is 2, so n square plus 19n plus 88 equivalent to 0. So I got minus 11 and minus 8. Minus 11 and minus 8. N value is minus 11 and minus 8. So I got two values. Please ensure that here I am adding 4k square. It is nothing but 2k whole square. It is nothing but 2k whole square. Why am I adding, multiplying by 4? Because I want to get it in the form of a plus b whole square. Otherwise I have to do n plus 19 by 2 whole square and everything. That many complication, I don't want to do it. Avoid silly mistake. A very good question to check how many quadratic expressions can take a perfect square or not. Idea clear, right? Minus 11, minus 8. Another question. Now if you see this question, find all the integer for which the quantity n square plus 96 is a perfect square. N square plus 96 should be a perfect square. Most of the students, what they do is, they will keep factorizing it. K square minus n square equivalent to 96. I will stop it here. K square minus n square is k plus n into k minus n equivalent to 96. I will stop it here. I want to discuss a very important logic. X square minus y square equivalent to k. This equation has integral solutions. This equation has integral solutions only if k is an odd number and k is a multiple of 4. X square minus y square has integral solutions only if k is an odd number and k is a multiple of 4. So x square minus y square is nothing but x plus y into x minus y equivalent to k. X is an even number, y is an even number. Even number plus even number, even number. Even number minus even number, even number. X is odd, y is odd. Odd plus odd, even. Odd minus odd, even. First two cases. X is even, y is odd. X is odd, y is even. If I take the first two cases, x is even, y is even. Even plus even, even. Even minus even, even. That means k is divisible by 4. X is odd, y is odd. Odd plus odd even, odd minus odd even. That means it is also divisible by 4. That means if the right hand side is a multiple of 4, what is the conclusion? X plus y should be an even number, x minus y should be an even number. If you take these two cases, even plus even, even, even minus even, even, odd plus odd even, odd minus odd even, x plus y even, x minus y even. If x plus y even number, so these 2x, x minus y even number, 2y equivalent to 96. X into y is nothing but 24. Can I say k plus n is greater than k minus n? Sum of two natural numbers is always greater than their difference. So k plus n, and so we will write all the factors. 24 into 1, that means x is greater than y. 12 into 2, next is 8 into 3, next is 6 into 4. There is no other way we can write. 1 into 24, if I write, y will be greater than x, but x is greater than y. So how many cases we got? We got total 4 integral solutions for this equation. Because the right hand side is given as 96, which is a multiple of 4, I solved it in this way. Are you with me? If k is a multiple of 4, if k will be a multiple of 4, if x plus y is an even number, x minus y is also an even number. Any even number is of the form 2x multiple of 2. I hope this logic is clear. Don't keep on factorizing 96, 1 into 96, 2 into 48. Do it like this. I hope this question is clear to you. How many 3-digit numbers on cubing will give 44 as last 2 digits? There is a question on cubing. First we will discuss the concept. X cube and 50 plus x whole cube. has the same last two digits, has same last two digits if x is even. Very, very good concept, sir. X cube and 50 plus x whole cube has same last two digits if x is even. Proof. Listen carefully, sir. None of these concepts you will find in anywhere in the other YouTube videos. You have to come and sit and listen to my concept. Suppose 123. Last two digits of a number is 23. Last two digits of a number is 23. So last two digits of a number, it is nothing but reminder when you divide a number by 100. Last two digits of any number is when you divide a number by 100. If I expand this bracket, a plus b whole cube, a cube, next is 3a square b, next is 3ab square, and next is b cube. These divisible by 100, divisible by 100, x is an even number. Even number square means it is divisible by 4. These also divisible by 100. What is remaining? X cube. Extremely important key point. X cube 50 plus x whole cube has same last two digits if x is even. X cube 50 plus x whole cube has same last two digits only if x is even. If x is an even number, x cube 50 plus x whole cube has same last two digits. This is concept 1. Second concept, I hope the idea is clear. Second concept, concept 2. A concept 2. Very, very important logic. A perfect square. A perfect square. This is something which we already discussed. A perfect square never ends with 2, 3, 7 or 8. This is something which you already know. A perfect square never ends with 2, 3, 7 or 8. But from here, if I take the unit digit of a number, unit digit is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A perfect square never ends with 2, 3, 7 or 8. Pick the numbers which are 7, 2, 3, 7 or 8. On cube only I am getting a different number. 0 cube is 0, 1 cube is 1, 4 cube is 4, 5 cube is 5, 6 cube is 216, 9 cube is 729. Remaining all the numbers are nothing but the 10 minus unit digit. 2 cube is 8, 10 minus 3 it is 7, it is 3, 8 cube is 512. A perfect square never ends with 2, 3, 7 or 8. Only these 2, 3, 7 or 8 on unit digit. If I cube it, I am getting the unit digit which is the tens complement of the unit digit. 0 cube 0, 1 cube 1, 4 cube 4, 5 cube 5, 6 cube 6, 9. Or you can write like this. A perfect square never ends with 2, 3, 7 or 8. If I cube it, I will get 2, 3, 7 or 8 in the reverse order. 8, 7, 3 or 2. Are you all with me? 2, 3, 7 or 8 on cube is nothing but 8, 7, 3 or 2. X cube 50 plus x whole cube has same last two digits if x is even. First point. Second point is a perfect square never ends with 2, 3, 7 or 8. 2, 3, 7 or 8 on cube I will get another unit digit 8, 7, 3 or 2. 8, 7, 3 or 2. Idea clear? With this, we will solve this question. Once you understand this concept, it is very clear. How many 3-digit numbers? If you see your regular textbook, there will be an half page or a full page proof. I will make it into a straightforward seconds answer if you know this logic. ABC whole cube, it is ending with 44. If it is ending with 4, this will be 4. Yes or no? Just now we discussed 4 cube is 64. 14 cube is nothing but 2744. 4 cube is 64. What will be the next number? 64. How many 3-digit numbers? So it can be 114, 214, 314, 414. It can be 164, 264, 364 and 464. Are you all with me? How many 3-digit numbers? Till 3-digit numbers means it is till 914. It is till 964. 9 plus 9, 18. Single. Straightforward answer if you know the logic. ABC on cubing, I got 44 as the last two digits. C is nothing but 4. 4 cube is 64. Next number is 14. 14 cube is 2744. Last two digits is 44. Next number will become 50 plus x whole cube, 64 cube. So because it's a 3-digit number, tens place can be from 1 to 9. Here also tens place can be from 1 to 9. 9 plus 9, 18. Idea clear, right? Easy if you know it. How many 3-digit numbers on cubing? How many 3-digit numbers on cubing? Gives 28 as the last two digits. It is 8. Smallest number is 2 cube 8. Next is 12 cube. 12 cube is 1728. If it is 12, next number will be 62 cube. How many 3-digit numbers? Same thing. 112 to 912 or 162 to 962. Total 9 plus 9, 18 numbers. Idea clear? Very easy question if you know this logic. How many 3-digit number? Tens place can be from 1 to 9 on cubing. I hope the idea is clear. What is the concept that I used? X cube 50 plus x whole cube has same last two digits. Has same last two digits. This problem and the previous problem, right? I hope it is clear. What are the concepts that we discussed? X cube 50 plus x whole cube has same last two digits, x as even. These two problems. Then x square minus y square has k, has integral solutions only when k is divisible by 4 or k is an odd number. Question. Next one. How to make a quadratic expression into a square minus b square by multiplying by 4. How to check whether the answer is right or wrong using multiple methods. Usage of prime numbers in a perfect square. Usage of prime numbers. Fourth power is nothing but a perfect square. Sixth power is derived from perfect cube logic. Beautiful question, how to play around with the unit digit numbers. X power y is a perfect square under what conditions? Right? How to check whether the 3-digit number is a perfect square if you remove units place and the leftmost place. Armstrong number, digital sum. A perfect square will always be of the form 4p plus 2 or 4p plus, will never be of the form 4p plus 2, 4p plus 3. How to find out the numbers? I hope the idea is clear. Many examples that we have taken in this one. This is the session. This is the second session. Session 2 on perfect squares. In session 2 on perfect squares, we did the application of perfect square concept. A perfect square never ends with 2, 3, 7 or 8. A perfect square digital sum is always 1, 4, 7 or 9. A perfect square nature will be either 4x or 4x plus 1, or it could be a nature 3x or 3x plus 1. How to find out the questions of the form x square plus or minus 4y square, 4x square plus or minus y square, x square plus or minus 3y square, 3x square plus or minus y square, x square plus y square equivalent to k, x square minus y square equivalent to k. It has integral solutions only when k is divisible by 4 or k is an odd number. Or k is an odd number. X cube 50 plus x whole cube has same last two digits. Has same last two digits when x is even. Has same last two digits when x is even. Any perfect square never ends with 2, 3, 7 or 8. On cube I will get 8, 7, 3 or 2, which is that course. Thanks a lot. Thank you for watching this class. With love, Anil Nair.